Not sure why my video just cut off, but it did. Okay. We were here. A biconditional. If an A, and we're doing the converse, then 90% or above. That's a true statement. That's a true statement. So both of these are true. The statement's true, the converse is true. So therefore, this statement can be classified as a biconditional, and we can write it using if and only if. So 90% or above if and only if an A. That's that. If and only if we can use only if it's called a biconditional. Okay, example 2. Here we go. Use the conditional statement if angles form a linear pair. Angles form a linear pair. That's like your P. That's your hypothesis. Then they are supplementary. That's like your Q. If P, then Q. If P, then Q. Write the converse and state its truth value. So the statement saying linear pair implies supplementary. So the converse would be Q implies P. Supplementary implies linear pair. If supplementary, then linear pair. Saying LP for linear pair. So I'm abbreviating, and you can do the same if you want. But there it is. If angles are supplementary, then they're a linear pair. Here's an example of two angles that do not make a linear pair. They're not even connected, but they are supplementary. They add up to 180. So this is actually a false statement. Write the inverse of the statement. So go back up to here. P implies Q. So we need not P implies not Q. So if not a linear pair, then not supplementary Q. Not P implies not Q. That is a false statement, and the same counterexample works. These are not a linear pair, but they are opposite of this conclusion. They are supplementary. So that makes this a false statement. Contrapositive is not Q implies not P. Not Q implies not P, so not supplementary implies not linear pair. If not supplementary, then not a linear pair. It's a true statement. If you're not supplementary, you can't possibly be a linear pair. Is the conditional statement biconditional? This statement was true. The converse was false. So not a biconditional. In order to be a biconditional, the statement and the converse have to be true. Example 3. Which statement is logically equivalent? So that means they have the same truth value. That means they're both, whatever, if I have a dog, then I have a pet. That's a true statement. So we need another, which of these is also a true statement? That would be logically equivalent. Okay, so if I have a dog, then I have a pet. That's true. Is it true that if I have a pet, then I have a dog? That's the converse. In this scenario, if you have a pet, what if you have a cat? That makes this false. This is a false statement. That's not the correct answer. If I do not have a dog, then I do not have a pet. Let's come back to that one. If I do not have a pet, then I do not have a dog. Ooh, this is getting complicated. I have a dog if and only if I have a pet. This is true and this is false. This phrase you can only use in a biconditional. This is not a biconditional because the statement's true and the converse is false. Alright, if I do not have a dog, then I do not have a pet. If I do not have a dog, I could have a cat, which makes this false. I do not have a pet. C is the correct answer. And C is the contrapositive of this statement. if I do not have a pet, if not Q, then not P. I do not have a dog. That's the one we're looking for. Example 4. State sometimes, always, or never. If two angles are a linear pair, then they are always adjacent. It's in the definition of linear pair. Have to be next to each other. The sum of two acute angles is sometimes acute. For example, 30 plus 30 is 60. Acute plus acute is acute. But 60 plus 60 is 120. Acute plus acute is obtuse. So sometimes. You need to pause the video and do these by yourself. That's what we would do if we were in class. I'd have you work on these alone, maybe partner up, and then we'd come back and do them together. Vertical angles are never adjacent. Again, vertical angles are always across from each other. They're never next to each other. Two lines that do not intersect are sometimes parallel. Got the first time we use that word this year, parallel. These lines do not intersect. They are parallel. These lines do not intersect. They're on a different plane. See? They are not parallel, so it's sometimes. Two lines parallel to the same plane intersect. This is hard to go over because I'd have us look at the ceiling. All the lines in the ceiling are parallel to the floor. Some of the lines in the ceiling are parallel to each other. Some of the lines in the ceiling intersect. Sometimes. Two lines parallel to the third line. So if the blue line is parallel to the red line, and the red line is parallel to the green line, what can we say about the blue line and the green line? If the blue line never intersects the red line, and the red line never intersects the green line, then the blue line never intersects the green line. The two lines of the third line are always parallel. Okay, moving on. Inductive versus deductive reasoning. There's two types of reasoning that your brain works through. First one's called inductive. It's less complicated, but it's not necessarily a good way to make decisions. Here's why. It uses patterns to reason. But sometimes patterns don't always work in the real world. Example, every day for the past week, the number of COVID cases has increased. So, based off of that pattern, my conclusion is that today the number of COVID cases will increase, and tomorrow the number of COVID cases will increase. You see the problem here? Can we use the past to predict the future? Can we? Is that always okay to do that? In what sense? To what extent is it okay to do that? Because eventually the number of COVID cases are going to go down, and our pattern will not work for our reasoning. Whereas deductive reasoning uses facts, definitions, accepted properties, and laws of logic to reason. So for example, Mr. Smith stated that cheating on an exam results in a 0. I stated that. That's a fact. If you cheat, you'll get a 0 if I catch you. Therefore, my conclusion is, if I get caught cheating, I'm going to get a 0. I'm basing this conclusion off of this fact. It's not a pattern, it's based off of a fact. So this is called deductive reasoning. State if the reasoning used is inductive or deductive. For the past month it has rained every day at 3, therefore I am planning on it raining after school today. So the past patterns, it's rained. So according to the patterns, it's going to rain today. That's inductive. Inductive. If the sequence starts with 3, 6, 9, 12, then the next number is 15. based off of the pattern of adding 3 here and adding 3 here and adding 3 here, to get to the next number, I think I'm going to have to add 3. That's inductive. Once again, I'm basing that off of a pattern. It is true. It is an accepted truth that having a TV, computer, or cell phone on during homework time interrupts your brain's ability to think. That is a true fact. That is a fact. Now, based off that fact, I'm going to make a conclusion. I'm going to conclude that I will do better on homework if I turn my TV off. Okay? This is deductive reasoning, because you're basing it off of a fact. That says deductive. D for deductive. It is true that vertical angles are congruent. That's a fact. For a reason, if 1 and 2 are vertical, then they're congruent. That's deductive reasoning again. You're basing it off a fact. The conclusion is 1's congruent to 2. You're basing that conclusion off of a fact. Next, counterexample. The hypothesis is met, but the conclusion contradicts the statement. So here's the statement. If 1 and 2 are a linear pair, then 1 is congruent to 2. So that is true in this scenario. Here's angle 1 and 2. They are a linear pair, and they are congruent. They're both 90. Here's a scenario where 1 and 2 are a linear pair, but it contradicts the conclusion. 1 is congruent to 2. Not true here. This is called a counterexample, and it makes the statement false. If you can find one counterexample to a statement, it makes it a false statement. Like if your mom always says, "You never clean up your room," and you say, but remember in 2012, on the day of August 17th, I did clean my room. Therefore, Mom, your statement is wrong that I never cleaned my room. You found a counterexample. Statement, on Mondays you go to school. Counterexample, do you go to school on Mondays? Today's Monday. You were in school. However, what about Labor Day? Labor Day is a counterexample. It's a Monday that you did not go to school. Alright, let's keep working here. Almost done. State true or false. If false, give a counterexample. Okay. If n is even, then n plus 2 is even. Let's see here. Let's make n 10. 10 is even. 10 plus 2 is 12, and 12 is even. I think that's just a true statement. Right? That's just a true statement. So we can't find a counterexample to that. Can we find an example where you add 2 to an even number and it doesn't turn out even? I don't think you're going to find that. The claim is if n is even. So you have to start with their claim. Is this, could we use 13? 13 plus 2 is 15. Hey, 15's odd. But we didn't start with the same claim that they need to start with. You have to start with the hypothesis and then see if you can contradict the conclusion. Next, if n is even, then n times 3 is odd. Let's see here. 10. 10 times 3 is 30. Haha, that's a counterexample. We started with an even number, we multiplied by 3, and we got an even number. That contradicts the claim of odd. So this is now false. This is a false statement. We contradicted the claim. If x is between a and b, then the length from a to x is the same as the length from b to x. Here's my counterclaim. How about a length of 3 and a length of 5? X is between a and b. So check. Hypothesis met. Conclusion false. These are not the same length. This says they are the same length. I've got an example of them not being the same length. That makes that a false statement. It's a counterexample. Next, the sum of two numbers is always more than the greater number. 2 plus 3 is 5. 5 is bigger than 3. Huh. So maybe this is true. Can you think of a situation where this is not true? Negative 2 plus 3 is 1. 1 is not bigger than 3. So this is a counterexample, which makes it a false statement. And here, the sum is less than the bigger number. This says it's always more than the bigger number. I don't want to get into this one. Other stuff. A negation of a statement is the opposite of a statement. So if the statement is it is not going to rain, the negation is it is not going to rain. Or it is going to rain. So the opposite of it is not going to rain is it is going to rain. What's the opposite of it being cold? Hot? Is hot the opposite of cold? No, not in math. The opposite of cold is not cold. You're either cold or you're not cold. That's the negation of cold. Next, this is other stuff. What is the next number in the sequence? So we're just looking for patterns. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. Alright, that's as far as I'm going to take us today. I'm not going to work on this today. Alright, enjoy.